Recall what we studied in session 1 concerning the definition of computers, classification of computers, and the characteristics of computers. Recall that we said whereas the computer can be defined in various ways depending on the uses to which it is being put, such definition must essentially encompass three important things, namely input, process, and output. And the fact that computers can be classified in three different ways, either by size, by purpose, or by signal. When we say by size, then we mean, is it micro, mini, mainframe, or supercomputers? By type, we mean, is it special purpose or general purpose? Or by signal, when we refer to whether such computers are analog, digital, or hybrid. Hybrid being a combination of analog and digital features. In this session, however, we want to look at the history of computers. And by way of introduction, the history of computers have come a long way, starting with the antiquated Chinese abacus, then going to Jacquard-Loom in 1805, Charles Babbage analytical machine in 1834, up to the conversion of mechanical, simple and digital computing processing designs of the 1960s, up to late 1960s, when we have advent of analog computers that are routinely used for finite difference equations arising in oil reservoir modeling, up to the time of digital computers, which presently dominate the global computing scene. In this session, at the end of this module, learners should be able to understand the history of computers, identify the various generations, as well as determine the underlying technology behind each generation. So, in looking at the history of computers, having done that, we should be able to classify them into various generations dictated by the underlying technology behind each of such generation. Going by this table, we start with the Chinese abacus, which was invented around 2500 BC, named abacus. The technology consisting of beads strung on rods in a frame, with the capability of being able to undertake simple calculations. This was followed by Napier bones, invented by John Napier around 1550 to 1617. The technology consists of small rods with markings, and Napier bones were able to perform multiplication and division in logarithms. Then comes the slide rule, invented by William Aldrich around 1622. The slide rule consists of rules with markings and can undertake logarithms, trigonometry, as well as exponentiation. The adding machine was invented by Blaise Pascal in 1642 and consists of rectangular box with movable dials. It can undertake addition, subtraction, multiplication, as well as division. That is, it can perform simple arithmetic calculations. The mechanical multiplier was invented by Gottfried Leibniz in 1694, and the technology consists of a system of dials and gear and can perform multiplications. The Coleman's calculator, invented by Charles T. de Coleman in 1822, had mechanical systems of gears and was a more practical approach to computing. The Jacquard-Loom, invented by Joseph Jacquard in 1801, made use of punch card machine as its technology and is always referred to as a mechanical computer. Charles Babbage in 1861 invented the analytical as well as the difference engine. These machines made use of steam technology and has the capability to store of stored programs and automatic printing. Then came the era of adding machine, invented by Herman Hollerith in 1891. Herman Hollerith adding machine also made use of punch card reader and were able to automatically tabulate their output. So they are normally referred to as having the capability of automatic tabulating machine. Now we move on to the generation of computers. Computers are classified according to generations, and they are classified into 5 such generations. We now look at these generations in turn. Starting with the first generation computers, they came into being around the middle of 1940s and made use of vacuum tubes as their logical circuitry, that is, as the underlying technology. They can process approximately 5,000 basic operations per unit, and they have about 500 milliseconds as access time, that is the time to access each basic operation. In terms of power consumption, they consume very high power and generate very much heat. They cannot be programmed, so they are hardwired, that is, they are made to solve only one specific problem, so they are hardwired to solve such a problem. They are about the size of a hall, which means the first generation computers were very big and their cost was very high and can only afforded by governments. Examples include ENIAC, referred to as Electronic Numerical Integrator and Calculator. The second generation of computers came into being between 1951 and 1965. The technology consists of diodes and transistors, unlike vacuum tubes in the first generation. The basic operations per unit improved considerably from the 5,000 it used to be for first generation to 50,000 operations per unit. And the access time was also considerably shorter, taking about 50 microseconds. The power consumption was not as high as that of the first generation, which makes them moderate. The heat generation was also moderately low. The second generation computers were programmable, and they were programmed with Fortran programming language. In terms of size, they are not as big as the first generation, being about the size of a room. But in terms of cost, their cost relatively was still high and affordable only by corporations. Examples of such computers include UNIVAC, meaning Universal Integrator and Variable Automatic Calculator. The third generation computers came into being around the late 1960s to mid 1970s. They were made up of large-scale integrated circuits, normally shortened to LSI, and they heralded the use of microprocessor. The basic operations per unit were approximately 50 million, considerably higher from that of the second generation, as well as the access time, which takes around 0.05 microseconds. The power consumption was expectedly low, with corresponding low heat generation. They continued the era of programmability, and they were able to be programmed using what is referred to as high-level programming procedural languages. We'll still come back to that as well. In terms of size, they can always fit on a tabletop, and so they are normally referred to as desktop. The cost is low, and can be afforded by small businesses. Examples include desktop computers. Talking about the fourth generation computers, they came into being between 1981 and 1989. Their technology was made up of very large scale integration and powerful microprocessors. The basic operations per unit is approximately 5 gigabits per second, while the access time is about 0.5 nanosecond. In terms of power consumption, they are quite efficient. The power consumption extremely low and the corresponding heat generation extremely low. They can always be used in office environments. They can be programmed using fourth generation command languages and database languages, in addition to the languages of second and third generations. They are miniaturized computers, that is, their size very small and the cost is correspondingly low. Examples include personal computers, the so-called PCs. The fifth generation computers dated to around the mid-90s. The technology consists of massively parallel processors with nanotechnology, while the basic operations per unit consist of hundreds of terabits per second. The access time is several fractions of picosecond. By picosecond we mean 10 raised to the power minus 12 of a second. So it is extremely fast. The power consumption is extremely low and the heat generation is also low. In terms of programmability, they normally make use of artificial intelligence languages, the so-called AI languages. Of course, in terms of size, they are relatively big and their costs. When we say low cost, that does not mean it can be afforded by individuals. No, but we are saying in comparison with first, second, third generations, comparing their versatility in terms of technology, in terms of operations per unit, programmability, and size to the other generations, then the costs can be said to be very low, even though it is not within the range of an individual. Examples include supercomputers. This is what we want to look at in this session: the history of computers and how they can be classified into generations based on their technology, the underlying technology. That is the basic tenet of this session. And so, in summary, we notice that in this module, we examine the history of computers from the early days of the Chinese abacus to the recent digital evolutions that is dominated by digital computers. Similarly, we categorize development along the line of the technology of their processing units into generations. And we highlighted how they started with the vacuum tubes in the first generation up to this day, when artificial intelligence handles majority of the decisions being made by computers. That is, from the first generation whose technology were vacuum tubes to the fifth whose technology is massively parallel processors and nanotechnology. By this we have come to the end of session 2 in our discussion.